Hello guys. So we are starting with this particular chapter of relations and functions. It's an extension to the chapter of set theory. Okay. Now if I write A is equal to A comma B comma C. Okay. A is equal to A comma B comma C. So this represents a set. Now this particular set has three objects, that is A, B and C. Okay. So set is a collection of well-defined objects. Okay. Now if I write one more set, B1 comma 2, right? And there is something new that you need to learn, that is Cartesian product of two sets. So A cross B. So this is the Cartesian product of A and B. Okay. So it will be A comma 1, A comma 2, B1, B2, C1 and C2. So this is the Cartesian product of A and B. Now when I say B cross A, so this is the Cartesian product of B and A. Now what happens basically is when I say B cross A, within the round bracket, before the comma, the first object will come from set B, okay, not from set A. So it will be 1A, 2A, okay, 1A comma 2A, right? Then 1B comma 2B and 1C comma 2C. So this basics you should know of Cartesian product, right? Now Cartesian product is a set of ordered pairs. Now these are set of ordered pairs. Okay, these are all ordered pairs. This round bracket within the curly brackets, each and every round bracket is called as an ordered pair. Okay, the first object comes from the first set, the second object comes from the second set. Okay, in that order. Now first object is called as first component, or it is also called as pre-image. The second object is called as second component, or it is also called as image. The second object is also called as second component, or it is also called as image. Okay, first component and second component. So everywhere, each and every ordered pair will have first component and second component, first component comma second component. Okay, so you should know all these things. Now let us understand few more concepts over here. N of A, N of A is equal to, in this case it is M, let it be M, and let it be, and it is equal to 3 because there are three objects. N of B is equal to N. There are two objects over here. Okay, N of A is M represented using M. N of B is equal to N represented using N, and the number of objects in set B is 2. Okay, so N of A cross B is equal to M cross N, which is equal to 3 into 2, which is 6. So A cross B, the Cartesian product of A and B, will have 6 ordered pairs. So let us check whether there are 6 ordered pairs. Yes. Look at A cross B. So we are having first ordered pair, second ordered pair, third, fourth, fifth, and sixth. 6 ordered pairs. Okay. Now N of B cross A is equal to M cross M, N cross N. So 2 cross 3, which is equal to 6. So number of objects in the set B is 2. Number of objects in set A is 3. So there are 6 ordered pairs, 2 cross 3 or 2 multiplied with 3. Let us verify this information. Look at B cross A. There are 6 ordered pairs. Okay. So I hope everybody understood the introductory part over here, that is Cartesian product of two sets. So let us go to the exercise and solve a few problems based on this concept. Let us go to exercise 2A. Let us go to exercise 2A. Okay, question number 1. X belongs to 2, 4, 6, 9, and Y belongs to 4, 6, 18, 27, 54. Okay, so we are supposed to write all ordered pairs. If you are looking at the question, we are supposed to write all ordered pairs such that x is a factor of y and x is lesser than y. Okay, so we'll write down all ordered pairs and we'll list down all the ordered pairs over here. So the first ordered pair, we'll target 2 over here. Okay, so 2 is a factor of what? Is 2 a factor of 2 itself? Yes, but then it cannot be, used. X should be less than y. X and y should not be equal. So first let us compare 2 with this 4. Okay, is 2 a factor of 4? The answer is yes. So the first ordered pair is 2 comma 4. Okay, now what is a factor? When we break down this 4, do we get 2? The answer is yes. Okay, so that's why 2 is a factor of 4. Then is 2 a factor of 6? Try to break down 6. 6 is 3 into 2, so we got 2 over here. Yes, so 2 is a factor of 6. Likewise, 2 is a factor of 18, because if we break down 18, definitely we'll get 2. Then finally 2 is a factor of 54. Okay, so that also we are going to mention over here. 2 comma 54. 2 is not a factor of 27, so we cannot write 2 comma 27. Let us start with 4. 4 is a factor of 4. Yes, but then both the terms should not be equal. X should be less than y. Okay, so equal terms don't consider it. Then 4 is a factor of 6. Not really, because when we break down 6 into multiples, we cannot get a 4. Okay, 4 is a factor of 18. Try to figure out that. No, 4 certainly is not a factor of 27, and 4 is not a factor of 54. Okay, because in the table of 4, 54 does not occur. Let's go ahead with 6. 6 is a factor of 6. 6 is certainly not a factor of 4, but then 6 is a factor of 6, but then we cannot write 6 comma 6 because x should be less than y. Okay, 6 is a factor of 18. Yes, 6 threes are 18. 6 is a factor of 27. No, that cannot be the case. Is 6 a factor of 54? Yes, 6 comma 54 is one ordered pair, because in the table of 6 we certainly get 54. Let's start with 9. 9 is not a factor of 6 and 4, obviously not, because in the table of 9 we don't have 4 or 6. So 9 comma 18, then 9 comma 27, 9 comma 54. Okay, so we have listed down the ordered pairs over here. Okay, let us go to the second problem, question number 2 of the same exercise. So the ordered pairs are x minus 2, y plus 5 is equal to minus 2 comma 1 by 3, minus 2 comma 1 by 3. So what are you observing over here? The thing that we are observing over here is, in the left hand side we are having an ordered pair, in the right hand side we are having an ordered pair. Okay, and both are equal to sign is given in the problem. So by comparing, by comparing. Okay, x minus 2 is equal to minus 2. So first component will be compared with the first component, and it will be equated because of the equal to sign, and the second component will be equated to the second component. So this will give you 2 minus 2, x is equal to 0. Okay, and y plus 5 is equal to 1 by 3. Y is equal to 1 by 3 minus 5. So 1 minus 15 by 3. Y is equal to minus 14 by 3. Okay, so that is what the value of y is, right? So I hope the basic calculations you know. Let us go to question number 3. A is given as 1, 3, 5, 7. B is given as 2, 4, 6. Okay, so the first part, A cross A. Now A cross A is nothing but Cartesian product of A with itself. Okay, so 1 along with itself, then 1 along with the rest of the objects in set A. Okay, so that was for 1. Then 3 with all the objects of set A itself. So 3, 1, 3 with itself, 3 with 5, 3 with 7. Okay, then 5 with 1, 5 with 3, 5 with itself, 5 with 7. So 5, 1, 5, 3, 5, 5, and 5, 7. Okay, and then for 7, 1, just a second. So it will be 7, 1, 7, 3, 7, 5, 7, 7. So this is the Cartesian product of A with itself. Okay, we'll answer question number 5 in the same slide. In sub question 5, they are asking n of A cross A. So count the number of ordered pairs over here. So that is equal to 16. Okay, yes. Now second part of the problem. Second part, they are asking A cross B. Second part of the problem, I'll just write down A and B for your reference once again. 1, 3, 5, 7. B is equal to 2, 4, 6. So A cross B. First component will be from the first set. Second component will be from the second set. 1, 2, 1, 4, 1, 6. Okay. Then 2, 2, 2, 4. Sorry. It will be 3, 2, 3, 4. Take the second object over here. 3, 2, 3, 4, 3, 6. Okay. Then 5, 2. The first component will come from the first set. 5, 2, 5, 4, 5, 6. Then 7, 2, 7, 4, 7, 6. Okay, second component will come from the second set. The second set over here is B. Fine. So I'll answer question number 6 as well. N of A cross B. Okay, so count the number of objects over here. So that's 4 3s are 12. Fine. Okay, and moreover, what you can do is these are 4 objects, these are 3 objects. N of A cross B will be M into N, that is 4 into 3, which is equal to 12. So likewise, you can calculate as well. Fine. So that was question number 2 along with sub question 6. So sub question 3, 4, 7 and 8. You can try it on your own. If you're not getting the solution, you can definitely ask that to me once again. So this all things you can try it on your own. Okay, let's go to question number 4. Question number 4, that is true or false. Sub question 1. P is equal to M cross N. M comma N, sorry. P is equal to M comma N. Let me just write this very precisely. Okay, we cannot put round bracket because it is a set, right? And Q is NM. So P cross Q. P cross Q will be MN MM. Okay. Then NN NM. Okay. So this is P cross Q. But then what they have mentioned over here is they have mentioned something else. They are writing P cross Q as M comma N and N comma M. Right? Now, ideally, there should be 4 ordered pairs, but then they are mentioning only 2 ordered pairs. So the answer is false over here. Okay, whatever they have given, this is false. This is not true, right? Okay, yeah. Let us go to the second sub question. They are asking whether the given Cartesian product is a product set a comma y bx by. Okay, so let us consider the first set to be a. So the first component will come from the first set, that is a, that is a comma b, small a comma b. Okay, and let this entire thing be a cross b. Second component will come from the second set, that is b. So x and y. This I'm assuming. Capital A is equal to a comma b, capital B is equal to x comma y. A and b, these are first components, so it will come from the first set. X and y are second components, so it will come from the second set. So if you calculate a cross b, will this be the right answer? Or any other ordered pairs are possible? I don't think so any other ordered pair is possible. So it's a product set. So the answer is true over here. It's a proper product set because no other ordered pairs are left out. Okay. Let us go to the third sub question. N of A is equal to X. N of B is equal to Y. Okay. A intersection B is null set. Okay. And N of A cross B. So N of A cross B is equal to X into Y, which is XY, which is quite true. Okay. I have used the notations of Mn earlier. So the N of A cross B will be Mn. But then by that logic, instead of Mn, they are using XY. So the number of ordered pairs in A cross B will be XY. So hence it is true. Fine. Let us go to the next problem. That is question number 4 of true or false. Right? A and B are two non-empty sets. Then A cross B is a non-empty set of ordered pairs X comma Y such that X belongs to B and Y belongs to A. Now A cross B is a Cartesian product which has ordered pairs X comma Y. So X should come from A and Y should come from B. But then what they have mentioned, X is coming from B and Y is coming from A. This is not really the case. This shouldn't be the case. The first component should definitely come from the first set. Second component should come from the second set. Okay, and they have given the reverse way. Hence it is false. Had it been they are mentioning B cross A. Okay, instead of A cross B in the problem, if they are giving you B cross A, then the answer could have been true. Fine. Yeah. So let's go to the next problem. That is question number 5. Sub question 1. Okay. Prior to that, they have given A as 1 comma 2, B as 3, CS 4 comma 5. So the first part, LHS. LHS is given as A cross B union C, right? So what is A? A is 1 comma 2 cross B union C. B union C is 3, 4, 5. So as per Cartesian product, I'll just list down the ordered pairs over here. 1, 3, 1, 4, 1, 5, 2, 3, 2, 4, 2, 5. Okay. Then RHS. RHS is equal to A union B cross A union C. So first we'll find out A union B. I'll take you to the previous slide. A union B. So it is 1, 2, 3. Okay, right? A union B is 1, 2, and 3. So that I'll just write on the next slide. 1, 2, 3. A union C. A union C, just combine the elements of A and C. Anything that is getting repeated, so just ignore that, write it only once. So there is a cross product over here. Okay, Cartesian products. So 1, 1, 1, 2, 1, 4, 1, 5. Then 2, 1, likewise. 2, 1, 2, 2, 2, 4, 2, 5. 3, 1, 3, 2, 3, 4, 3, 5. Now just observe guys the LHS and the RHS. This is the RHS. Look at the final answer of the RHS in this particular problem. Now look at LHS. Now here there are only 6 objects, whereas here there are so many other objects or ordered pairs. Okay, so in this case LHS is not equal to RHS. Fine. Okay, let's go to the second sub question. Fine. So LHS, A cross B intersection C. Now what is A? A is 1 comma 2. B intersection C. B intersection C. What is common between B and C? There is nothing in common between B and C. There is nothing in common. There is intersection sign. There is nothing in common between B and C. So this is a null set. Okay. RHS. A cross B intersection A cross C. Now A cross B is not a set. A cross B is a Cartesian product. So let's start with that. A cross B, 1, 3 and 2, 3. Fine. Intersection A cross C. Let us understand what is A cross C. So look at the sets A and C. 1, 4, 1, 5. 2, 4, 2, 5. 1, 4, 1, 5. 2, 4, 2, 5. So this is A cross B and this is A cross C. Is there anything in common between the two? I don't think so. The answer is no. Nothing is in common. So this is also a null set. So both cases we are getting a null set. Hence LHS is equal to RHS. Okay. Let's go to question number 6. Let's go to question number 6 and solve it further. A is equal to 1, 2, 3. B is equal to 3, 4. And C is equal to 4, 5, 6. Fine. So what over here they're asking is A cross B union A cross C. So A cross B. I'll just list down what is A cross B on the next slide. So it is 1 3 1 4 2 3 2 4 3 3 3 4. Okay, 1 3 1 4 2 3 2 4 and 3 3 3 4. This is A cross B union A cross C. How to calculate A cross C? Look at A. The first component will come from A. Second component will come from C. So 1 4 1 5 1 6. Then 2 4 2 5 2 6. Then 3 4 3 5 3 6. Okay, I'll just list down that on the next slide. 1 4 1 5 1 6. 2 4 2 5 2 6. 3 4 3 5 3 6. Okay, now we have to find out the union of this. That means combine both the Cartesian products. So 1 3 1 4 1 4 is already included over here. Then 1 5 1 6. Then 2 3 2 4. 2 4 is repeated twice, but then write only once. 2 3 2 4 2 5 2 6. Then 3 3 3 4 3 5 3 6. Okay, yeah. So that is your final answer for this particular problem. That is question number 6. Question number 7, you can try it on your own. Okay, so basically question number 7, you can take it for self study. They might not ask you the graph for it. Okay, if you are keen to understand what is a graph, you can let me know. I'll just help you with that. Okay, later on. Let us go to question number 8. Some elements of A cross B are AX, CY, DZ. So A cross B, some of the elements, not all, some of the ordered pairs. AX, CY, DZ. Okay. Only 3 ordered pairs are given. Rest of the ordered pairs are not given. Now A is given as ABCD in the problem. It's given to us. That means the first components are ABCD. B is not mentioned anywhere in the ordered set, but then B is mentioned over here in the given part. Okay. So B has to be one of the objects in A. Okay. Now B, set B. Second components will be a part of set B. So that is X, Y, Z. Okay. And like A, they have not mentioned what is B. So by common sense, we have written what are the values of B. Okay. Now what are they asking? What are the remaining ordered pairs? They should mention ordered pairs. They have mentioned elements, but then it is ordered pairs of A cross B. So remaining ordered pairs will be written as follows. AX already written. Don't write it once again. AY, yes. AZ, yes, it's a remaining ordered pair. Then BX, BY, BZ, Okay, then CX. Okay, start with CX, right? CY is already there. See, it's already there. Don't write it once again. CZ, then DX, DY, DZ is already written. Okay, so see DX, DY, DZ, but then DZ is already written, so no need to write that. So these are the remaining ordered pairs. Okay, then question number 9. Let us go to question number 9. The ordered pairs 1, comma 1, 2, comma 2, 3, comma 3 are among the elements in the set A cross B. So A cross B have the following ordered pairs 1, 1, 2, 2, 3, 3. Okay. A and B have three elements each. N of A is equal to 3, N of B is equal to 3. So A will have three elements, B will have three elements. Okay. So N of A cross B, technically speaking, it will be 3 into 3, that will be 9. Okay. So there should be 9 ordered pairs over here, but then 3 are given to us. So the first components are always a part of the first set. Second components are a part of second set. So that is the value of A and B. Okay. A cross B. So A is 1, 2, 3, B is 1, 2, 3. How many elements in all does set A cross B have? So that is 3 into 3, that is 9. And remaining ordered pairs. Now remaining ordered pairs you can calculate using the previous sum, the concept that I've taught you in the previous sum. Don't write down this 3 ordered pairs once again. Just write down what is left in A cross B. Okay, fine. So remaining ordered pairs, I'll just list a few. 1, 1. Don't write 1, 1 once again because it is already included. You can write 1, 2 and 1, 3. Okay, 2, 1. 2, 2, don't write once again because it is already included. 2, 3. Then 3, 1 and 3, 2. Don't write 3, 3 because it is already included. Fine. So these are the remaining ordered pairs which I have listed down for you. Okay. Let us go to question number 10. Question number 10. Now see, A is 1, comma 4, B is 2, 3, 6, and C is 2, 3, 7. Okay. First part, LHS. A cross B union C. So what is A? A is 1, comma 4, B union C. So it is 2, 3, 6, and 7. Okay. So the Cartesian product of these two sets. So 1, 2, 1, 3, 1, 6, 1, 7, 4, 2, 4, 3, 4, 6, 4, 7. First object will come from set A and the second object will come from set B union C. 4, 2, 4, 3, 4, 6, and 4, 7. So this is the LHS. Let's go to RHS. RHS is equal to A cross B union A cross C. Okay, so A cross B. So I'll just write down A cross B for you. It is 1, 2. You can take a look at the textbook. The question is there in it, and you can find out set A, B, and C over there. 1, 2, 1, 3, 1, 6, 4, 2, 4, 3, 4, 6. This is A cross B union A cross C. So 1, 2, 1, 3, 1, 7, 1, 3, 1, 7, 4, 2, 4, 3, 4, 7, 4, 2, 4, 3, 4, 7. Okay. So union for these two sets. So 1, 2, 1, 3, 1, 6, 1, 7, 4, 2, 4, 3, then 4, 6, 4, 7. Now just take a look at LHS and RHS. Are we having the same LHS over here previously? 1, 2, 1, 3, 1, 6, 1, 7, 4, 2, 4, 3, 4, 6, 4, 7. And take a look at RHS. 1, 2, 1, 3, 1, 6, 1, 7, 4, 2, 4, 3, 4, 6, 4, 7. LHS is equal to RHS. Okay. Second subpart. We'll start with the second subpart. Yeah. So LHS A minus B cross C. Now A is equal to 1 comma 4 and B is equal to 2, 3, 6. So A minus B. This is the minus operator. 1. Keep focus on set A. 1. Is this object 1 in set B? No. So just include it. 4. Is this 4 in set B? No. If it is there, then don't include it. If it is not there in set B, include it. Okay. 1 comma 4. So we got A minus B, that is 1 comma 4. And C. C is nothing but 2, 3, 7. So this will be 1, 2, 1, 3, 1, 7, 4, 2, 4, 3, 4, 7. This is your LHS. This is your LHS. Okay. Let us start with RHS. RHS is equal to A cross C minus B cross C. Now A cross C is the Cartesian product of A and C. 1, 2, 1, 3, 1, 7. Then 4, 2, 4, 3, 4, 7. Minus B cross C. 2, 2, 2, 3, 2, 7. And 3, 2, 3, 3, 3, 7. And 6, 2, 6, 3, 6, 7. 6, 2, 6, 3, 6, 7. So we have to apply minus operator between these two. Now 1 comma 2. Is it in the second set? No. So included. 1 comma 3. Is it in the second set? No, just included. 1 comma 7. Is it in the second set? No, just included. 4, 2. Is it in the second set? Second Cartesian product? No. So just included. 4, 3. Is it in the second Cartesian product? No, included. And 4, 7. It's not there in the second Cartesian product, so included. So this is the final answer of RHS. Now, if you observe, the LHS and RHS are same in this case. Okay, so LHS is equal to RHS. I'll show you the previous slide if you want. See, look at the LHS final answer, and this is the RHS final answer. Okay, let us go to question number 11. Question number 11, you can very well take it for self-study. I'll be solving question number 12. Question number 12. N of A is equal to 3. N of B is equal to 2. They have given this information. And A cross B are having certain ordered pairs over here. Those ordered pairs are x comma 1, y comma 2, and z comma 1. Remaining ordered pairs are not given. Can someone tell me what is n of A cross B? N of A cross B will be 3 into 2, which is equal to 6. So there will be 6 ordered pairs, out of which 3 are given to us. So we'll write down what is A and what is B. Okay. First component always comes from the first set. So x, y, z from the first set, that is set A. And second component will be from the second set. 1, 2, 1. But then 1 is repeated. So 1 and 2 from the second set. So there are 3 objects and there are 2 objects. So in this problem, they are asking you only the values of A and B, which we have noted down. Okay. Let's go to question number 13. Right. A cross A has 9 elements. So n of A cross A is equal to 9 elements. So n of A has to be 3. Okay, it has to be 3 because it will be 3 into 3, that will give you 9. It is Cartesian product of A with itself. And A cross A, when I say A cross A, they have given you certain objects over here, ordered pairs. -1, comma 0 and 0, comma 1. Okay, out of 9, they have given you 2 ordered pairs. Okay, so A, first component will be from the first set, -1 and 0. It has to go to set A. Okay, now see, second component. The second component should go in the second set, and the second set is A itself. So this 0 should be a part of A, which I have already written. Okay, and this 1 should be also be a part of the second set, that is A. Okay, so I'll include this 1 in set A. So set A is nothing but -1, 0, 1. So now you're supposed to find out A cross A. Okay, you can just find out A cross A Cartesian product with itself. Okay, and the remaining ordered pairs, if they're asking you certainly in the problem. So exclude the this 2 ordered pairs in the remaining set, so that I leave it up to you. Okay, but then the main task over here was to get A. So in A cross A, what are the remaining 7 ordered pairs that you need to find out? For that reason, you first calculate A cross A and exclude the 2 ordered pairs which are given to you. One last question. Okay, so they might ask you something like this: A cross A cross A, where A is equal to -1, comma 1. So first we'll do this. We'll find out A cross A. That is Cartesian product of A with itself. So that is equal to, just wait a second. I'll just rewrite this for you. This will be equal to A cross A -1 along with itself, then -1 along with 1. Okay, then 1 along with itself, 1 along with itself, and 1 along with -1. Okay, so this is A cross A, which has a cross product with A itself. So A is -1, comma 1. Right? So now see how we are going to calculate this. -1, -1, -1, first ordered pair. Then -1, -1, +1. Okay. So the first ordered pair is done over here. Second, -1, 1, -1, 1, -1, then -1, 1 along with 1. Okay, and for the rest two, I'm leaving it up to you. There will be 4 more ordered pairs. Okay, so that I'll leave it up to you. I hope you understood how to calculate A cross A cross A. That's it. Thank you.